So yesterday we left off talking about the fact that all matter can be subdivided into elements, compounds, and mixtures. We dove right in, got very specific with elements and compounds, but we did not do that with mixtures. So today we're going to look at the two types of mixtures, homogeneous and heterogeneous. Yesterday we talked about how mixtures are kind of like your parents, the marriage, where you've got a couple that go in and they become one legally. Nevertheless, they're still made up of two different people. Okay? And those different people still retain, even though they're married now, they still retain their own personalities. Which means they bring in all the positives and negatives, and unfortunately, for about half of the American population, the negatives eventually drive them to separate. Okay, in the same way, mixtures can be separated using physical means. There are two kinds of marriages. There's homogeneous mixtures, and there's heterogeneous mixtures. Homo is the prefix that means the same. So if it has the same consistency, if it appears to be the same, if to you it looks like a pure substance because you can't tell the different parts, then it's a homogeneous mixture. If it's obvious to you, okay, there's the one part, and here's another part, and here's another part, if you can clearly see the different parts that make up this mixture, then it's heterogeneous. Heterogeneous. Now, there is a word that we will use synonymously with homogeneous mixtures, and that is the word solution. So from now on, if I say the word solution, I mean homogeneous mixture. If I say homogeneous mixture, I mean solution. So most of the time in chemistry, a solution will appear to be just water. For example, drinking water is a solution. There's all sorts of stuff in there. Can you tell where the stuff is? No. It's all, the consistency is the same throughout. But there's stuff in there. So water, drinking water, is a solution. If I was to say distilled water, purified water, then that would be a, would it be a mixture? It would be a compound. Good job, Ryan. It wouldn't be a mixture at all. All right, let's look at three possibilities here. Potassium dichromate, potassium chromate solution, cobalt 2 hydroxide mixture, and this one. Depends. What if I was to say drinking water? What would this be? Homogeneous or solution. Very good. Because there's stuff in the drinking water. There's chloride to disinfect. There's fluoride to strengthen your teeth. There's all sorts of minerals that just leave there because it's not going to hurt you. What if I was to have said it was distilled water? Max, compound. Heterogeneous would mean that you could see the different parts to it. Okay, this next one. I took these yellow crystals and I poured them into the test tube, and pretty soon the yellow crystals disappeared. I poured them into a test tube with water. Pretty soon the yellow crystals disappeared, leaving behind yellow water. What is it? Raise your hand. Viet. It is a solution. Why? Can't see the crystals. Are they there? Yes. But you can't see them. It looks like it's just yellow. But this one. I took some purple cobalt 2 hydroxide and I poured it in water in this test tube. Some of it dissolved. That's why it's purpley water, but some of it did not. Raise your hand. Phobia. Can you see where the cobalt 2 hydroxide crystals are? Can you see where the water is? You can see it. It's heterogeneous. What marble? Marble is a metamorphic rock. Homo or hetero? Noah? And how do you know? Yeah, the streaks. Mineral, different minerals. Actually, your desktops is a faux marble facade. And that's French. Faux, F-A-U-X, meaning? False. That's right. So that's supposed to look like it's marble. It really isn't. Can you see all the different minerals there? Is it exactly the same? Will it look exact? If you were to take snapshots of different parts of that desktop, would it look exactly the same? Heterogeneous. How about some gasoline? One of the easiest ways to determine whether something is homo or hetero is whether you have to shake it or not, especially if it's a liquid. If it says shake before using, it's heterogeneous because it settles out. Do you have to shake gasoline before you put it into your tank? No. So it must be? How about water from a stream? With gravel? Raise your hand. With gravel, yes. Raise your hand. Allison. Can you see the gravel? Can you see the fish? Can you see the water? Hetero. How about air? Ryan. Homo. Are you ever walking down the street or walking down the hallway and you're talking, you're gossiping about your friend, and then you go, oh, okay. In other words, do you ever reach a patch of air that has no oxygen in it? Only in China. Yeah, that's right. Yeah, Chinese, the Beijing has terrible. Los Angeles, we've got our own city with terrible pollution. So you can almost say that, yeah, Los Angeles air is heterogeneous because you can actually see the smog, and Beijing is just as bad. But for the most part, air has the same consistency. How about this? That's a peacock. It could have been a French horn. Could have been a trumpet. Brass. Raise your hand. Noah? Can you see where the zinc is? Where's the zinc? Oh, where's the copper? If you were to see it under, by the way, all homogeneous mixtures are heterogeneous underneath the microscope, wouldn't it? If you were to look at this in the microscope, it would not look that uniform. But we don't talk about that. When we're talking about whether it's homogeneous or heterogeneous, we're really talking about a more far-off look. Can you tell where the zinc is? Can you tell where the copper is? How about this one, a copper pot? Raise your hand. Phobia. Homogeneous. You're wrong. Lenoir. Heterogeneous. No, you're wrong. Ishtar. It's an element. Look back here, gang. Copper is an element. I tricked you. Got you, Phoebe. What about vino? Wine. Vine. Ryan.
Compound. No. Yes. Yes.
So that means that every bit of wine tastes the same. It's always the same thing. You see, what a compound is always the same thing.
Homo.
It's a homogeneous mixture. Very good. A wine is a combination of alcohol, water, and flavorings. What makes wine, what you have different kinds of wine are the flavorings. And so this, can you see where the alcohol is? Can you see where the flavorings are? Can you see where the water is? Homogeneous. I had a student was talking about how their parents are they shake the wine before they're drinking it. Before they drink it, they shake it. They twirl it around. Why? Does anyone know? They thought, well, that must be heterogeneous if they're shaking before using. Yes. Well, what are they doing by swirling it? What are they doing to the surface area? Increasing the surface area, therefore they are increasing the evaporation, therefore okay, how do you taste? Do you taste with your tongue or do you taste with your nose? Mostly with your nose. Okay, you can taste 4 things with your tongue. Sweet, salty, sour, and spicy. Bitter, right? Okay, that's it. That's all you can taste with your tongue. Everything else happens with your nose. So Phoebe is absolutely right. They're trying to get that odor up there so when they do drink it, it's more flavorful. There's more flavor because there's more stuff going up into their nose. How about the combination of helium and oxygen in a scuba tank? Do they sometimes take a breath and go, I'm Mickey Mouse? I'm not Mickey Mouse anymore. I'm Mickey Mouse. Or does it all blend together?
It all blends together.
So it would be?
A solution.
How about oil and vinegar salad dressing? See, somebody new. Come on. Beth, thanks. Why? What's the... Can you see the layers? Not only that, but Noah's right. You got to shake it before you use it. Here's a toughie. Table salt. Marie. Probably not. If it was a compound, then that would have been the most expensive table salt that your parents have ever bought. I can buy a small bottle of pure sodium chloride for about $60. Or I can go to Walmart and get some table salt for about 35 cents. What's the difference? What's in the bottle that's $60 is compound. What's at Walmart for 35 cents? It's a tainted compound. Okay, it's going to have sodium chloride, probably some sodium nitrate. There's going to be other compounds there that in low amounts are not going to hurt you. And actually we may need it for our diet. For example, if it's iodized salt, they'll add some potassium iodide there. Do you ever take some salt, put it on your french fry, eat a french fry and go, ooh, that salt tasted funny? No, because it's homo or hetero?
Homo.
Homo.